Question 3. Potassium bromate reacts with potassium bromide and sulfuric acid to form this potassium sulfate, bromine and water. Okay, this is equation. Now, a student is investigating how the rates of this reaction is affected by the change in the concentration of the reactant in turn. This is done by keeping the total volume of the mixture constant and adding different small volume of each reagent. This is a standard procedure to change the concentration. Now, the reaction produced bromine, which is orange in color. The student times the reaction and then determines the rates as 1 over time. So this is a rate. Now, the rate equations for the reaction is this one. Later we need to compare the results, means A, B, C, D, E, to get the order X, Y, Z. Okay, later we'll do it. And the K is the rate constant. Now the student carry out the experiment and obtain the following data. So this is the concentrations that involved and the rates of reaction. We'll discuss this one later. Part A1 suggests how the student might time the reaction and judge the endpoint of the reaction for each mixture. This one you can actually use two methods. You can use the colorimeter. So this one is the one that measures the color intensity. Means it's actually about absorbance. Means if more color that produced, then is higher absorbance. Okay, so means when it's produced certain amount of the bromine, so when it's reached certain absorbance, then we will stop the timing. So we can we can measure the time that taken when a fixed value of this absorbance has been reached. Okay, let's say now we set one absorbance value. If let's say now the bromine keep on produce, absorbance is getting higher and higher. When it's reached the values that we set, then we stop the timing. So therefore we can get the time for each of these reaction mixture. This reaction mixture, okay, is produced different time. So that's why we get different rates. Okay, this is how we do using this meter. This is using the meter. If you don't want to use this method, also can. This one using instrument. You can actually use something that can delay the formations of bromine. Okay, so let's move back to this reaction. Because these reactions, we know that when all these reactants react, it will form bromine. And of course, these two, right? So bromine is the one that form color, is the orange color. And this formation is actually immediate. Means when you add these three, you straight away will see the orange color. So we can actually delay the formations of bromine by adding something. So what are we going to add? We need to add something like phenol. If let's say now you already learned organic chem, so you should know this reaction. If not, so please go to the benzene related compound, okay, the organic chem, then you'll know this reaction. So we can use the phenol, and we know that bromine water will react with phenol and bromine decolorized, and it will form this 2,4,6-tribromophenol. So if let's say we put a small amount of phenol in the reaction mixture, the bromine will not really form yet. So after certain time, when all the phenols gone, so the bromines will form and you see the orange color. So that's how we use the so-called the clock method. The clock method means use timing. So this is what you need to do. Add a fixed amount of phenol to the reaction mixture. If you use, let's say, this certain amount, make sure use the same amount for all. And of course, this shouldn't be in excess, or else you will never see bromine. Okay, so this one, add fixed amount of phenol to the reaction mixture. Okay, after that, measure the time taken for the orange color to form. Actually, once we mix the phenol to the reaction mixture, so we start the timing. After that, we stop the timing when we see orange color. This is what we do using the clock method, which is mentioned in the mark scheme. Now, part 2. This part is quite easy to get the order of this reactant. In order to get X, so we compare A and B. Okay, so let's move on to A and B. A and B, we are comparing this one, the first reactant. So this one all cancel out, no need to compare. So from here we know that when this concentration double, the rate also double. So times 2, times 2. So we know that this reactant is first order. So means X is equal to 1. So to get the orders for the second reactant, the KBr, so we compare A and C. A and C is this. A and C. So this one removed. Okay, this one removed. So when this concentration double and the rate also double, so therefore we know that the orders for this KBr is also first order. Okay, so Y is equal to 1. To get the the last one, okay, the Z, so we compare A and D. A and D, so this one removed, this one removed. So we compare this. When concentrations double, now the rate times 4. So therefore we know that this reactant is second order, right? So means Z is equal to 2. Part B, the student carry out each reaction using boiling tube, which the capacity is 50 cm3, and vary the concentration by adding different volume of each reagent. So means, for example, in mixture A, 5 cm3 of this KBrO3 is required. Okay, name the suitable piece of apparatus which could use to measure this volume. Because the reactants now, the volume is important, means it will affect the rate. So it's better to use a more accurate apparatus. Means those bigger measuring cylinder is not really suitable. So it's better to use burette to get the volumes. Part C, suggest why the reagents are heated in the same temperature before mixing. So this one, because this is the rate of reaction, so the reagent must be the same temperature before they react. So means we must make sure all the reagents at the same temperature, then we mix it, then is a more reliable result, right? Because okay, this one, different temperature of the reagent will affect the rates, so it must keep constant. Okay, so for part D, this is dilution. So how we're going to make the more dilute solution. Now, the solution of sulfuric acid used in each mixture, okay, was of this 0.15 mole per dm3. This acid was prepared from a solution of concentration 1 mole per dm3. So describe how you make the more dilute solution and stating the capacity of any apparatus used. First, you need to calculate the volume, means the volume of the 1 mole per dm cube solution. Okay, what is the volume step need to take? First, we need to use M1V1 equal to M2V2. So let's say we use 250 volumetric flask here. So means the V2 is 250. The concentrations that need to prepare is 0.15. And the initial concentration is 1 mole per dm cube. V1 is the one that we need to take. So is 37.5 cm cube. Means if we use 250 cm cube volumetric flask, so we need to take 37.5 cm cube, okay, from the more concentrated solution, this one. Now let's start. Use burette to take 37.5 cm cube of 1 mole per dm cube H2SO4 solution. Okay, so this is the apparatus that we need to use. And transfer the acid to 250 volumetric flask. So must mention the volume and the apparatus. After that, top up to the calibration mark. The volumetric flask itself, on the neck, it has one mark we call calibration mark. So we just add water until this calibration mark, and we must use distilled water. Okay, so that's all. Thank you.